All right, we're on the last lesson for the course. We're starting on page 521, and we're going to give an explanation of why the derivative of ln of x is what it is, and why the derivative of e to the x is what it is, and also show you where the definition of e comes from. So if you look on page 521, if we have a function y equals e to the x, then the inverse function of that is y equals ln of x, or y equals log base e of x, whichever way you want to think about it, means the same thing. And then we also know from what we learned in lesson 98 that the natural log of x is equal to the integral from 1 to x of 1 over t dt. Remember, that was, can't remember which theorem of calculus it was. The fundamental theorem of calculus part 2. All right, so that implies that if we take the derivative that it's equal to 1 over x. And we can use that to find the derivative of e to the x. So if we have y equals e to the x, and we take the natural log of both sides, so ln of y would be equal to x. And then if we take the derivative of both of those, then we get d dx of ln of y equals d dx of x. So this is just equal to 1, and this is equal to 1 over y dy dx. So if we solve for dy dx, we get y, and y was equal to e to the x. So dy dx equals e to the x. All right, so we just proved both of those derivatives. Okay, on page 522, we're going to go over the definition of e to the x. Everybody always asks me what e is. Where does it come from? And it's always saved for the last lesson of the year. So here is the basic definition of e. It's the limit as x approaches infinity of 1 plus 1 over x raised to the x power. Now, initially, you would think that because 1 divided by infinity is going to 0, that this would be 1. But that's not the case, because remember, as x goes to infinity, this x is also going to infinity. So if you put this in the table in the calculator like they show on page 522, so we're going to go into y equals and put in parentheses 1 plus 1 divided by x, close the parentheses, raised to the x power. And then we'll go to table set, and we're going to start set table start and table, okay, both of them to 100. Okay, oops. And then we'll look at the table. So there's the table. Okay, and as we go down in the table, it goes to 2.7179, and the approximation that we typically use is 2.718. So E is approximately 2.718. And now you know that's where it comes from. Okay, so right above 102.1, there's another little, not trivial fact, but a little fact that we should be aware of. E raised to the a power is the same as the limit as x approaches infinity of 1 plus a over x raised to the x power, which is the same as the limit. Oh, let me go to the next line. I'm not going to have enough room. It's equal to the limit as x approaches infinity. Gosh, this is terrible. Just got a new pen, guys, so I'm trying to learn how to make it work. Of 1 plus 1 over x raised to the ax power. That's for any real number a. We're not going to prove it, just know that these two are equal. So in 102.1, we have letter A says, find the limit as x approaches infinity of 1 plus pi over x raised to the x. So if we come in here and let u be equal to x over pi, then this becomes 1 plus 1 over u. And then if we solve this for x, x would be equal to u pi. So this x would become u pi. And then if we go one step further, the limit as x approaches infinity of 1 plus 1 over u, and we bring this u back here and then have this raised to the pi power, then this right here is going to be, this whole thing is going to be e and then raised to the pi power. Okay. All right, last one says find the limit as x approaches infinity of 1 plus 1 over x to the x over 4. Now we don't have to substitute anything here as long as we recognize that this is 1 plus 1 over x to the x times 1 over 4. So it'd be like this. So then this becomes e, and then it's raised to the 1/4 power. So e to the 1/4. All right, so lots of good stuff in this last lesson. Thank you, guys.